Yeah, we're good. Friday or no? Or not?
We're back tomorrow.
Are we gonna meet before school tomorrow? Abby said she can. So
Davis,
I think we should do
we're going to have the
I'm the one
math
that's trying
lesson
to get
now.
this thing done, okay?
Actually,
Are you ready for
I
math?
set up something for yesterday,
I hope so.
except with the lab.
Okay, so what did we know? What did we learn? We learned the law of what?
Of dumb angles.
The law of sines. And that would work for what? We had angle, angle, side. Because if you have angle, angle, side, and it would work for angle, side, angle. Okay? Angle, angle, side, angle, 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 side, angle, side, angle. So if you had two angles in one side, it would work. Everybody remember that? The law of sines would work. And we have to be very, very careful. It will work, but be careful for what?
Angle, side.
Mhm. And this would also be like a side-side angle. And what does that mean? The angle that you have is not the included angle between the two sides. So the law of sines will work. Well, what else do we have? What could we have? We could have side, side, side. Why would the law of sines not work for side, side, side?
You don't know what angle that is.
I don't have an angle, right? At sine A over A, I don't have anything to take the sine of. And if I just tell you three lengths like 3, 4, 7, that has to make a triangle, right? It's no ambiguity. It has to make a triangle, but I don't have any what?
Angles.
I don't have any angles, and there's not a straightforward way like, how like you like to think, well, could you do this and then find this? Well, the problem is I don't have any angles at all. So side, side, side is a problem, as is if you have side, angle, side. Because the problem there is, what's the problem? I have this one, I have this one, and I have this one. But the problem is you want sine A over A. You see? So I don't have anything that I could work. So these two are the problem.
Just at that bottom one, can't you find H and then the side angle side, you find H and then do it that way?
You could find H and then you could try to work your way around it. You could probably eventually figure it out. Okay. But there's an easier way. All right. First of all, we learned the law of sines. We probably assume that there's going to be a what? Law of cosines is probably what we believe. And so what we do for SSS and SAS, we do the law of cosines. And really, I don't even think you probably have to memorize that. It's just if you try to do the law of sines, you see I don't have sine A over A. I don't have an angle and it's, I don't have an angle and its opposite side. I'm going to have to try something else. We'll then go to the law of cosines. All right. And just remember, be very careful with that one. Okay. So let's look at a right triangle. Okay. A right triangle, if this is A and this is B and this is C and this is a right triangle, what do we know? Chase, what do we know?
A squared plus B squared equals C squared.
Yes. A squared plus B squared equals C squared. Okay. But what we have to remember is that's only for what, Victor?
Right triangle.
Only for right triangles. Okay. So what if we have something other than that? So that's for this. A, B, C. That's for that. What if we have something like this? Okay. So this is A, this is B, and this is C. And we've got A, this B, and this is C. Okay. Well, for this case, and I could derive this for you. Really, it comes down to trying to make this and then working through it. And if you go through all the math, but I'm not going to go through all the math. But for this is what is true. C squared okay, is equal to a squared plus b squared, okay, but then it's minus 2ab cosine. What do you think I'm going to put here?
C.
Yeah. Isn't it funny how you can kind of develop intuition as far as cases go? C squared is equal to a squared plus b squared. So c squared is equal to a squared plus b squared, but you have to subtract off this factor. What do you think also? Now, in this case, C is very special, right? C is special. You can't interchange A, B, and C, right?
There's a lot of
Yeah. Is there anything special about C?
no.
No. So what can I also say, Will, if you were going to guess, B squared is going to be equal to what?
A squared plus C squared
Mm-hmm.
minus 2 AC
Mm-hmm.
cosine B.
Right. Okay. So, Franklin, what do you think C squared would be? Or I'm sorry, I already did two. A squared. Franklin, what do you think A squared would be?
C squared plus B squared minus 2 C
I'll say BC, just keep them in order. Okay.
BC cosine of A.
Yeah. Okay. So you see, you can still use the Pythagorean theorem. Now, what's nice about this is that even with three sides, if I had three sides, I could figure out what? One angle. And then once I had one angle, then I could use the law of sine or whatever to then calculate the rest of the things. So you see, you can use this to get you one angle. Or even if it was a side angle side, you could get it to get that included angle that you
Well, you
need.
could get that extra side, right? It would
Well,
give
once
you
I had that angle, then I could get another side. Right.
Yeah, I would.
But you see, you're jammed up because you have to get one angle. Once you have one angle, there's a lot of different ways to go. Okay?
Now, would it be, if you were going to get one of the sides, would you have to do, of course, you have to do square root of it, but would it be plus or minus, or would it just be a
I think
positive?
I think when you take the square root of this, you don't worry about plus or minus because lengths have to be positive.
Okay.
Okay. So you good, insightful question. I don't think you have to worry about the plus and minus now. Okay. All right. So let's work one. Okay. So let's say I have A is equal to 8, and then B is equal to 19, and let's say C is equal to 14. And so this is going to be C, this is going to be B, and this is going to be A. Okay. So Chase, where could I start to get an angle?
C squared equals
Okay, so let's just write it down. C squared is equal to
A squared
A squared.
plus B squared
Mm-hmm.
minus 2AB cosine C.
Yeah. So then I could say, I could move this over here, and I could say 2AB cosine C, that's over here, is equal to what? A squared plus B squared
minus C squared.
minus C squared. Okay. Then I could say cosine of C is equal to what? A squared plus B squared minus C squared. And then I would divide by what?
2AB.
Okay. And then what could I say? I could say C is equal to what? Cosine inverse
Yes.
of A squared plus B squared minus C squared over 2AB. So I like to do it this way before I put the numbers in. Now let's put some numbers in. C is equal to cosine inverse of what's A?
64.
64 plus B squared. What's 19 squared?
361.
Somebody check them on the
Yes.
calculator. Is it? Okay. And then minus what's C squared, Chase?
196.
196 divided by 2 divided by 8 divided by what? B is 19. Okay. Everybody put that in the calculator and let's see what we get. What'd you get, Noah?
41.12.
probably try it again. This was 2. I want to. Oh, this is 19. Yeah, that's 19.
No, you guys did it wrong.
That's 19. Somebody else try it. What did you
I
get?
tried to work
I
that
got
out.
an error. I did too.
Did you, are you in degrees?
Yes. So
Plus
64.
minus 9,
41.12.
Yeah, I'm still getting
Oh,
41.12.
Oh, okay. Okay, so,
Square root of that.
no, there's no square root, right? This was the one inside here. Okay, I'm sorry, you're right. What did you get? What did you get?
41.12.
41.12 degrees. Did everybody get that? Chase, did you figure out what you were doing wrong?
Yes, I was putting with parentheses.
Okay.
On the first time, I added 196 instead of subtracting.
Okay. So real quick, how could I get B? Like, we're on a roll here. How could I get B real quick?
Use the law of signs.
Well, no. Let's just do it this way, just because we know how to do this. So which one would I use?
B squared
Yeah, I would use B squared is equal to what?
A squared plus C squared. Minus
2AC what?
cosine of B.
Cosine of B. And so 2AC cosine of B is equal to A squared plus C squared minus B squared, right? And so cosine of B is equal to A squared plus C squared minus B squared over 2AC. Is this making sense? Franklin, tell me when I can go on. That's okay, Franklin. Okay, B is equal to what, Victor?
B is equal to cosine inverse of A squared B plus C squared minus B squared over 2AC.
Okay. Emily, give me some numbers to put in here.
64
64.
plus, what was C squared?
What's 14 squared?
196
Okay.
minus 361.
Over what?
2 times
8.
8 times 14.
Okay. So B is equal to what? What do you guys get for B?
One 116.8.
116.8 degrees. Now tell me two different, so I have A, I have B. Tell me two different ways to get, I got B and I got C. Tell me two different ways to get A.
Add them together and subtract.
Yeah, subtract them from 180, or you could go back and do this whole thing. What do you want to do?
Subtract.
Subtract them from 180 and you get A is equal to what?
22.08.
22.08. Okay, so now we have the three angles. Really, we don't have to do anything else because they gave us all three sides. We're what?
We're done.
We're what?
Done.
Dunskies. There you go. Okay. Does that make sense? Several different ways you could work it, right? So you got to see that you have different choices and just kind of look and see if there's one that's easier. Like, damn, I wouldn't do the whole thing for the third one.
We're deciding.
All right. Okay, so let's say that I have B is equal to 9. I have 25 degrees. C is equal to 12. and A is up here. So I have 25. So what would I call this? Of what? Side angle sine. So why would the law of sines not work as the first step?
Well, you don't have the,
Yeah, I don't have A and right.
yeah, you need more.
I need
info.
more. I need something else. So where should I start?
Well, let's find A squared.
Yeah.
Well, let's find A, I guess.
Yeah, so let's find A, and let's make sure that I had to find A, I would need what? I would need B and C in which angle?
A.
Do I have that? Yeah. So what I could say is A squared is equal to B squared plus C squared minus 2BC cosine A. So A squared is equal to, Victor, help me, what's B squared?
81,
Plus C squared is what?
144,
Minus what?
2,
Times what?
9,
12. C?
Yeah.
And B, I'm sorry, you were right, I should put 9 first. And then cosine of what?
25.
25. So A squared is equal to what? You guys put all of this in your calculator and tell me what A squared is. Okay, so that's what I got, 29.24, and then A is equal to what?
5.41.
5.4 we'll call it, all right? I don't have to do plus or minus because you can have a negative distance on a triangle, all right? Now, once we have that, how would you get, like the other things, how would you get angle B and angle C? Just the law of sines. Does that make sense? Is everybody okay with me going to the next problem? You know how to do the law of sines from this point. Always know that when you solve it, you got to get A, B, C, and you got to get A, B, C. You got to do all of it. But sometimes you can start with the law of cosines. Now it's the law of sines, which I think you already know how to do. Okay? So, there's one more thing that we have to learn today. All right?
That's what the homework is, right?
What's that?
One more thing we have to learn is what we have to do for homework.
One more thing you have to learn is Heron's formula.
Oh.
All right. How would I do Heron's formula? I would set up Excel spreadsheet, and then I would type in the numbers into Excel, and I would have Excel do it because it's easy. You just get it in Excel, right, and then you just do it. You can do it on the calculator, but if you put 20 numbers in the calculator, there's a reasonable chance you're going to mess up. Okay. So I would do it. So this is saying, if all I have is S, like I have A, B, and C, how would I find the area of that? Well, one way is you could use the law of cosines and figure out this angle, and once you had this angle, then you could find the area the way we were, didn't we do this the other day, find the area, or is that what you just turned in? Okay, you could do it that way, or there's a direct way that you could do it. And what you say is S is equal to A plus B plus C over 2, okay? And then the area of the triangle is equal to the square root of S times S minus A times S minus B times S minus C. Okay, so do you see how you could have, like in Excel, you could just have A, B, C, right? Like that. Or you could just put into Excel A, B, and C. And then what would you do? You would say S is equal to this, that plus that plus that over 2. And then you say area is equal to the square root of S. S, right. So you see, you could do it in Excel. All right, homework. This is chapter 6, section 2. Homework is 5 through 8, 13 through 15, 37 through 40. The bonus is 48. The bonus is 50. And the bonus is 54. Okay. We're at a new 6 weeks. This is a great opportunity to get a really good homework grade with 3 bonuses.
On the Excel, you want us to print out what we did, like if I created one Excel workbook
Just
and one big page and you did.
yeah, just do them all on the same page.
If I did 10 problems, print out
Yeah.
that one page.
Right,
and
that's
you turn it in. Okay.
Just show me that you've actually done it. Okay.
Okay.
Show me that you've actually
Can I
done it.
stop this?
Davis, we're going now. Goodbye.